Hi everyone, and welcome to our third episode of SFP podcast, brought to you by Students Fight Parkinson's, where we dive into a variety of neuroscience research and its impact on understanding and treating neurological disorders such as Parkinson's disease. I'm going to be your host, Daniel Kim, and today we are joined by Dr. Jessica Grahn, a professor in the Department of Psychology at Western. She is a cognitive and clinical neuroscientist who leads the Music and Neuroscience Lab, where she studies how brain perceives rhythm and music and how these processes relate to movement and neurological conditions, one of them being Parkinson's. Some of her many accomplishments before joining Western, Dr. Grahn conducted research at the MRC Cognition and Brain Sciences Unit at University of Cambridge. And she has an interdisciplinary background with degrees in neuroscience and piano performance from Northwestern University, along with a PhD in neuroscience of music from University of Cambridge. She has authored over 90 scientific publications and received numerous prestigious honors, including the NSERC EWR, correct me if I'm wrong, Stacey Fellowship.
Correct.
Okay, an Early Researcher Award from Ontario Government, and recognition as the member of the Royal Society of Canada's College of New Scholars. A bit of a mouthful there. So we're excited to have her here today to share her insight on how kind of music and rhythm can interact with the brain and how this research can kind of inform our understanding and treatment for movement disorders such as Parkinson's disease. So thank you for joining us today, Dr. Grahn. It is an honor to have you here.
Oh, absolutely. My pleasure.
That's great. Okay, so we can start off with a few kind of icebreaker questions I kind of had for you, which I think could be interesting to start off the podcast. One question is, what do you think is a useful superpower to have in your field and why?
I actually think the ability to be comfortable talking and mingling and meeting new people is something that is incredibly useful and very underestimated in our field, because science is done by humans, and we often think of scientists as like by themselves in the lab late at night, sacrificing everything for a scientific discovery. But in reality, it's a big group of people who are all really interested in different aspects of the same thing. And by far the most fun and the most interesting science I've done has been in collaboration with other scientists. Mm-hmm. And yet, scientists are often insecure the way many of us are. Mm-hmm. So many people don't feel comfortable putting their ideas out there or chatting informally or going and meeting people in their field that they might be a bit intimidated by. Mm-hmm. But it's such a great thing and leads to so much more interesting stuff, the science, the interactions, the collaborations, when you can actually do that. So that would be the superpower. I've developed that over the years. I wouldn't say I've got it as a superpower yet, but it's definitely helpful.
I think that's interesting because I think a lot of people expect science or STEM to be a lot more independent, but it's a lot more collaborative. Even like now furthering in my studies, I'm only in my third year, but I have realized like science as well, not only is it collaborative and not very independent, but it's also very creative.
Yes, there is definitely an element of putting different things together in new ways. And sometimes you do that and nothing comes of it.
Yes.
And sometimes you do that and you actually realize you've got something there to follow up. So I agree, it's very creative.
Yeah. I think it's really cool too. Like you get to kind of put all your expertise or different experiences. I think it's really interesting. Another question I have for you. What's something about you that students might be surprised to learn?
Yeah, I never know what about me is surprising. I suppose the main thing I can think of is that often when we look to people who are senior to us, who are in a field and have progressed through it to a reasonable level, we tend to assume they had a direct path there, that they made all of the right decisions. They always knew they wanted to do this. They just excelled at every stage of the way, and all of these choices that they made in their different career forks were intentional and well thought through and achieved through excellence. And so I think for some people, it's surprising when they find out that, for example, I did my undergraduate in neuroscience and piano, but I had no intention of combining them. I had thought that neuroscience, I would be doing hardcore neuroscience, and that neuroscience of music might be too fluffy or not very rigorous. And it took me a while to realize that actually, when you have the complexity of music and the complexity of neuroscience, then you have to be very rigorous in what you're doing. Otherwise, you don't really have the ability to interpret something you've found, because it could have been due to so many things in the music. For example, it could have been you find some effect of music on behavior. Maybe it was because people liked it and it put them in a good mood. Maybe it was because it was energizing and it got their arousal levels up. Maybe it's because it, primed some sort of cognitive process that was helpful. And if you're not rigorous and careful in teasing these things apart, you have an effect that you really don't know where it came from. So it was pretty clear over time that a lot of the science I was thinking of was informed by music, and I was clearly interested in music. So after graduate school, I had a better sense of, or during graduate school, I would say maybe after my undergrad and then after a year or so of graduate school, that, this is clearly where my heart is. So instead of resisting it, I should just dive in and do it the best I can.
Was there like I'm not sure, but was there like a specific moment where you were like, oh, this is the field I want to pursue?
That's a good question. I don't remember a specific moment, but I did have an opportunity. I started my graduate training in a lab that did memory research, and I was quite interested in skill learning. So this idea that there are memories we have for things we can do, like performing a piano piece, for example.
Right. Yes.
But we really can't access how to do that. Like if I try to explain to you, you have to put your fourth finger on your left hand here for this amount of time, and then it's far too complicated to really articulate anything about it, but the memory is there. And interestingly, people with amnesia have preservation of that kind of memory. So they can learn to do a new complicated motor task, never remember learning it, but get very good at it. So you might ask them, for example, one that they use is mirror tracing. So you trace an outline of a star, but you could only see your hand in a mirror. You can't see your actual hand. And people make lots of errors initially, but after a while they get pretty good. You can take someone with amnesia and train them on this task. And every time they sit down, you have to explain it to them again. And they say, this sounds impossible. But then by the 5th or 10th session, they're doing amazingly, and they have no access to that. So I was very interested in the separation of memory there. But the lab I was in was not a great fit. And it was very clear, as I said, that my interest was motivated a lot in music. So when I moved to Cambridge, I had a chance to restart. And there, somewhere in that transition, along that first year, I had really realized, music is where my heart is, and I want to do something related to music. And I had all kinds of different ideas I was interested in. This is one thing, people think they have to pick the right topic area right off the bat. It is absolutely not true. There's lots of opportunity to shift around and change. And a lot of us scientists, I think, have lots of different interests. So there isn't just one thing that I could do that would be interesting. A number of areas of music I think could have been super cool.
I think that's cool. Yeah, clearly, you said you switched from kind of different fields, like learning about amnesia. I guess you're referencing HM.
That's one of the most famous patients, absolutely.
I do remember studying about him.
Yeah.
It is fascinating.
It's crazy.
I can't believe that's how the human brain works. Every time I learn something about the brain, because I'm in neuroscience, I'm just I don't understand how it works. Like the whole I forget his name, the one with the pipe inhaled in his brain too.
Oh yes.
I can't believe that one
went
through. But yeah, I did actually want to ask you about kind of your expertise in music, and also I think it's super cool that you can study music and the brain, or neuroscience and the impact of music and rhythm in the brain. I do wonder what exactly drove you to study music to this depth? Is it just your passion for music, or is it more so just?
I think the earlier passion in terms of research was for neuroscience. I was so interested in the brain and how it works, and why people have different talents, and that's all down to brain differences. Absolutely, there are things that you can train and study and get better at. So the brain is plastic, which is also really interesting. But how these things intersect, I find fascinating. And then it was later I realized that actually a lot of the questions where I was really headed at a personal level, curious about how something worked, were related to music. There were other things I also had that bug for. I loved immunology, sleep, I found fascinating. But a lot of the techniques you use in immunology are very cellular and molecular. And I realized after my first couple years in my degree that the kind of research that you did at that level didn't drive me as much as the kind of research that involved behavior. And there, I think with music, there's something about being able to introspect about something and have an intuition or a connection about it, which you might be wrong about, and you might disprove whatever your intuition was. that I found more interesting. And so, yeah, some of that definitely was related to, okay, being able to perform music is crazy. And the emotional effects of music on people, that's nuts. Like, we pay hundreds of dollars for concert tickets where the sound quality is going to be terrible. Yeah. But to share this experience with other people that's driven by music. So all of these things I think are really interesting about it. So yeah, I think I knew I was really interested in the brain.
Okay.
And then the music part kind of directed that research interest later.
That's super cool. I think that's nice. I love music as well. I like listening. I like playing it. Do you play any instruments as well?
I do, yeah. So piano is my degree, but I much more often these days play cello. I'm in a community orchestra, so.
Cello is a beautiful instrument. I love cello. I love listening to strings orchestra. I think my most played album on Spotify is The Four Seasons by Vivaldi.
Oh, lovely.
I always listen to that one.
Yeah.
Yeah. I did actually have a few questions about neuroscience of music, which this has all been on my mind. And I'm curious, do musicians' brains process rhythm and music differently from non-musicians, do you think?
To some extent, yes. And it varies. So whenever we test people's rhythm abilities, we give them tasks like, hear this rhythm, now tap it back, let's see how good you are. Certainly people who work with rhythm, like percussionists or jazz musicians, where often they have to internalize a beat and then what they produce is really not emphasizing that beat very much. And so you have a lot of masking of where the beat is and when you're listening to it. And so it's kind of a fun game to be like, how much can I mess up the beat? But I'm still tracking it so that when this particular section is over, we move forward. And those people tend to, excel at these things.
Right. Yeah.
But actually for the majority of musicians, people who maybe grew up playing, there's a lot of overlap with people who've never done any musical training. So some people are great, hear a rhythm, tap it back. I only need to hear it once or twice and I'm set. And some people really struggle. And this is true even within musicians. And partly this can be related to how much ear training they did and playing by ear. Or how tied to reading a musical score they are versus being able to pick up something auditorily. So there are some differences, but the most striking differences really emerge at the higher levels when you're talking about the level of training that most of us who have some musical background but aren't professional musicians have. There's actually a lot of overlap. What we often have as musicians is a vocabulary to talk about rhythm. Like we know what a beat is and we know what meter means, this grouping of beats into 1, 2, 3, 1, 2, 3, or 1, 2, 1, 2, that kind of thing. Whereas this might be more implicit. People can sense it when they don't have musical training, but they might not have the terminology for it.
I see. I think some people are really talented in music as well. Like when I see someone who's I think the term is pitch perfect.
That they have perfect pitch or absolute pitch, sometimes we call it. Yeah.
Yes, absolute pitch. Or I have a friend who if I show them a song, they listen to a song, they can just play it on the piano right away.
Right.
And I'm just do their brains just work differently? I'm so amazed at how that can happen.
Yes. Yeah. To some degree, yes, because the brain gives rise to the behavior. Sometimes it's about innate capabilities. There are absolutely predispositions for some of these things that, for example, with perfect pitch, often if you have early training, you're more likely to develop it, but not everyone who has early training does. So there are variations there in how well people are likely to do that. Also with being able to play by ear. Some people have fantastic auditory memories and are very good at perceiving the structure. Again, some of that can be scaffolded by training. If I'm thinking of things in terms of chord progressions, that's a lot simpler than trying to memorize every single note that's occurring at every single time. That's too much information for anyone to process. So knowing the structures of music can really aid that, and then practice helps. But there are people who, with very little practice, seem to be very good at some of these things, and people who practice a lot and don't reach the same levels. So there's absolutely some inherent things going on there too.
Okay, so it's varied. It could be learned experience, it could be innate.
They both have influences for sure, yeah.
And on the other side of the coin as well, I'm curious, because I've also met someone who, I like to go karaoke sometimes, and I met someone who is very tone deaf and genuinely no offense to him.
Sure.
He's an amazing person. But the thing is, he's very tone deaf and he's very offbeat all the time. But the thing is, he doesn't know it.
Yes.
He thinks he's good at singing it, which is really interesting. And I was do they hear differently, or is it something in the brain? Like, is there a mechanism for that?
There have been studies of exactly this sort
Yeah.
of poor pitch singing versus poor pitch perception.
Right.
And for some people, it goes together that, you ask them, oh, here are two tones, bum, bum. Was the second one higher or lower? And they're terrible at saying which direction it went. But then you say, now sing this to me, and they'll go bum, bum. They'll get in the right direction, even though they said, oh, no, I think that was lower. So there seems to be varieties of poor pitch processing, some of which are, I'm terrible at all of the things. Some of which are, no, when you ask me what this percept is, I struggle, but if I just have to reproduce it, I actually do okay. Or people who sounds like your friend who just don't really have a precise coding of pitch. It's very general, so they probably go up roughly when the song goes up and down when the song goes down, but the precise notes and pitch matching, might not be good. And then there are people who selectively are poor singers. So they can hear fine, they can tell that someone else is out of tune, but you ask them to control their voice, to do that pitch matching while they're singing, and they struggle. Some of the work that's been done looks at connections between auditory and frontal areas, and finds that the white matter tracks that connect sort of auditory processing to like frontal more memory areas where you might be doing some of these comparisons between what I'm producing and what I'm supposed to be producing,
Right.
that those tracks are less dense, and that these areas might be less connected in people with poor pitch singing, and poor pitch perception, and that they might be selectively denser and have more fibers going along these tracks for people, for example, who have perfect pitch or who have excellent pitch perception and production.
Yeah, kind of on that topic, like talking about like the brain and music. So like, what exactly happens in the brain when we like listen to music? And I kind of want to ask this question because I am curious about like why humans are naturally drawn to like rhythm and music.
Yeah, there are lots of theories about where this drive came from. Certainly when people listen to music, it's not super surprising. You get a lot of auditory areas responding. You get activity in motor circuitry, so areas involved in like selection or timing or control of movement. Even when people are staying still, you often see those in response to the rhythmic features of the music. Emotional, limbic areas, hippocampal areas, memory areas. Almost all of these, just with passive listening, will respond. And then if you give people a task on top of it, sing along to this, tap along to this, identify the wrong note, then you'll get a whole bunch of task-related, frontal control and attentional areas that will come on board as well. In terms of how that might relate to, why we're drawn to music, there are a number of theories. One is that, music and language sort of evolved initially together, and then when language had the pressure evolutionarily for propositional speech, so actually conveying concrete information, which music doesn't really do, that music then separated off and became more of the emotional component, that it's used for expressing emotional states and conveying emotion. But there's also a lot about music and pressure related to communication in groups, and that groups that used music to move together and to signal their affiliation, particularly to other groups, were more cohesive and maybe more intimidating to other groups around them. So they had better survival compared to groups who don't. But there's lots of interesting cross-cultural research going on even now, finding groups, for example, that basically never sing. So there are a couple societies where it is just not as ingrained in life as we tend to assume it is based on our observations of other groups. So yeah, this is definitely an active area of research, people trying to work out what it is about music, how culturally universal is it, what are its benefits, to figure out why we developed this craving and love of this particular type of sound.
Yeah, that's interesting. I know in my I think it was evolutionary psych class where we talked about like human nature and like absolute universals, conditional universals. And from the sound of it, music sounds like something that's like a conditional universal.
It might be. I mean, certainly everywhere I think you would say they have some form of music, but it's perhaps slightly less in some cultures than we had thought.
Okay, interesting. Another question I had kind of about music is like, why does music have like a strong effect on the brain comparatively to other sounds as well?
Yeah, I think there are a couple angles to it. So one is language also has a very strong effect. Like if you've ever tried to not understand what someone is saying to you, it's impossible, right? The processing is so automatic. And we have an entire, hypothesized module in the brain in early childhood meant to learn and understand language, which then, gets repurposed for other things or disappears, because when you learn that language when you're 20, it's nothing the same as like when you were learning it when you were 3. So I think because we don't think about language much because it's so part of our mundane daily lives, we sort of dismiss that it also has tremendous effects on the brain, and the brain is absolutely tuned to language as well. But you're right in the sense that music often has this, again, emotional component. People form their identities, related to music. So the music that you tend to hear in early adulthood tends to become part of your identity longer in life, like other things do. Fashion and hairstyles and things from those times are near and dear to your heart for a long time. So yeah, I think it is unclear, except again with these evolutionary theories, the idea that music is somehow this socially bonding experience, and that is an important part of human culture because it sort of bonds people together and it creates shared experiences. It's often part of ritual, all of these important cultural things that our brains are then wired because of evolution and through this long cultural co-evolution as well, that like it's also part of our historical society lineage. These things all together make it very important to tap into. So I don't know if it's actually more privileged or not, but certainly it feels more mysterious because of the types of effects it can have on us. Okay.
That's really great. I think I want to also move into now Parkinson's disease, kind of segueing into there a little bit. I guess first of all, for like the people who might not be unaware, could you explain a bit about Parkinson's disease, like what it is?
Sure, yeah. So Parkinson's usually arises from, it's called idiopathic, no known cause, although 5% of the time approximately it is genetic, but often it arises de novo. And it's caused by the death of dopamine-producing neurons in a deep part of the brain called the substantia nigra. And the lack of dopamine over time as these neurons die off starts to really disrupt circuits. Often the first thing that people notice that leads to a diagnosis would be a tremor or movement problems, but it actually has disruptive effects throughout the brain.
Right. Why do you think Parkinson's symptoms affect movement so strongly?
Yeah, there's a lot of work on this, and motor circuitry is complex, but the best analogy I've heard is that the lack of dopamine causes basically a part of the brain that gates movement. So all the time when we're looking at other people, we're often semi-simulating what they're doing. Or if I want to just move one hand, the motor coding for that same movement in the other hand is often being planned but inhibited. So there's a lot of movement that we're actually inhibiting at any given time. And what I've heard referred to in Parkinson's disease is as if you have a brake that's pressed too much. So that inhibition of movement that is a normal part of the balance of controlling movements, so we don't make unwanted or overly large movements, goes wrong in Parkinson's, such that now they want to make movements, but they can't because these inhibitory neurons are overactive, preventing activity from allowing a movement to occur.
I see. And you briefly mentioned the lack of dopamine as well. Does that also affect people beyond movement disorders? I know depression is a very common side effect of Parkinson's as well.
Yes, absolutely. So we see often mood-related changes, changes in facial expression. For example, they talk about the Parkinson's mask, where emotional expressions are not conveyed as strongly as they are in people without Parkinson's. Cognition is also disrupted, so trying to make connections, and sometimes people even talk about their thinking being slow. And yes, mood disorders are common as well. In particular, sort of depression or apathy can be a feature. Right. Yeah.
Okay. And kind of bridging, I think, Parkinson's and music that we just talked about. So I know you have a few studies on rhythm and Parkinson's. How did you become interested in kind of those two?
Yeah. That came from outside. So I wasn't aware when I started my PhD looking at rhythm in the brain that there were people with Parkinson's who found a metronome or some sort of external cue very helpful. And it was my PhD advisor who brought this up as something that was, and then sometimes visual cues could also help, but the idea was that some sort of external cue can help improve movement. And so there it became, why would rhythm have privileged access, this auditory sound, to the motor system in such a way as to help this? And so it sort of became a part of why we were interested in rhythm as related to movement, and not just a sound, but like, what's going on with rhythm processing, because it was clear that rhythm had these effects on the motor system in certain people.
I see. That was actually kind of, you almost answered it, but that was gonna be my next question. Like, so there have been like many cases and studies where like rhythm or music have like helped people either like walk better. I've seen them using like rhythm and beat to kind of help their walking. How and like why does this happen in the brain?
So we don't know is the short answer, but of course we have speculative ideas. It's variable across people. So some people do show very strong responses. A lot of people show measurable but not super exciting responses. Some people are actually made worse by trying to walk to music.
Oh, interesting.
Yeah, so it's not always beneficial. On average, it is, but for any given individual, there will be people who respond and people who it really just doesn't seem to do anything for. There are a couple ideas about how this might work in the brain. One is that the external cue activates a part of the motor system that is specifically about externally cued action. So one paradoxical thing that happens in Parkinson's is, for example, if you ask someone, can you reach your hand out for me? They might have a delay or some freezing of movement before they can actually get that movement to go, and it might be quite slow, the movement. But if you throw a ball and ask them to catch it, that movement is now perfectly fast in time to intercept the ball. So there's something about the external trigger that seems to normalize movement. And generally in the brain, we sort of think of the cerebellum and premotor cortex as part of this externally cueing related system. So one idea is that music is just a nice external cue, and like that's why a metronome might work as well, that it helps pace that movement using these areas that aren't as affected in Parkinson's. Another idea is that the music itself is so rewarding, and that maybe the dopamine that's released through that reward can help compensate a little bit for the lack of dopamine generally in the system. And then a third idea is that there's something about that steady beat that sort of boosts activity in the basal ganglia and a different part of the motor system, the supplementary motor area. So it's a more middle of the brain type area, midline area. And that the increased activity in those areas sort of helps boost what is normally under activity in those. So we don't really know. These are the ideas that we have. We've seen some studies, like for example, after people have been trained with an intervention like this, and then we scan their brains afterward, we sometimes see more cerebellar activity. So that's some evidence for this external cueing hypothesis. But there's definitely more work to be done there for sure.
For sure. I remember, speaking of the external cue, like kind of like the first idea, I remember when I was in neuroscience class, we learned about this patient. I'm not sure if he was a Parkinson's disease patient, but he couldn't walk, this patient. However, he could bike perfectly fine.
Oh, yes.
Yes. So I remember Dr. Corneo, I think it was, he showed us the video of him having difficulty walking, and they asked him, how did you get here? And he just biked here. And they were like, how did you do that? And we just see him biking completely normal. And I think the idea they got was it was due to the external cues, like that movement, like whether that's like the environment around the air. But I thought that was fascinating.
It is so interesting because it's such a dramatic shift for some patients.
Yes.
Yeah.
And also kind of speaking on like rhythm and beat, I did have like one curious question. Like, is there a specific type of rhythm or beat or music that works best when kind of improving movement for Parkinson's or neurological conditions? Or do you think more so maybe it's just like they choose like a steady beat, like a metronome?
This is a great question. So this is exactly some of the work that we're doing behaviorally with people, is just trying out different types of music. And we're looking at whether liking it matters, if it's music you love versus music that really doesn't do it for you. The steady beat and how clear that beat is. So sometimes we emphasize the beat in the music. We add some extra drum into it to really make sure the beat is very clear.
Right.
And then another idea is that you can just ask people, how much does this music make you want to move? And we have operationalized that in psychology as groove, which is also known as the pleasurable urge to move to music. And what we find is if you ask people how much this music makes them want to move, that very highly predicts responsiveness. But a metronome is often similar. So I think the beat salience is really part of it for many people. And it might be that what the music adds is just, this is now a pleasant intervention, and I'm enjoying listening to this. And any intervention that can be improved in terms of its experience is much more likely to be effective and useful because people will want to do it. Whereas maybe walking to a metronome all the time, for some people, might not be very, very pleasant. So right now we're finding that in general, music that makes you want to move and that metronome both seem to work fairly well compared to music that has less of that feeling of, oh, this really makes me want to get up. Interestingly, in the one study we've done so far, how much people liked it really didn't matter.
Oh, I see.
In that study, we wanted to use unfamiliar music because often familiarity and enjoyment are completely confounded. I play stuff I like, and so I'm going to be more and more familiar with it because I like it, and vice versa. And so it's really hard to tease those things apart. So to get rid of that, we just chose things that people didn't know. And then we found that really it didn't matter. Often it's like, picking genres people don't like. So maybe you're not a country buff, but country is often quite groovy. You get this sense of wanting to tap your foot along. So I think sometimes that's where these come from, these dissociations come from, is that you might not love it, but the beat is getting in there anyway. So you still have that feeling of like wanting to tap along, even if you're like, this is not what I would put on the radio if it was my choice. But there's still more to be done for sure in terms of exactly who benefits from having that clear beat. And maybe there are some people where liking the music is really important. So trying to characterize all that individual variation.
Okay, I think that's interesting. I think I also had a question. It's like, so why do people kind of like feel like an urge to like tap their foot or move along to music? Why does that happen?
It's a great question. Yeah. So we've done a number of imaging studies that show indeed when people are trying to interact with rhythms, either mentally, like trying to remember them or detect changes in them, or actually physically, it's really the motor system that's involved. Like you have sound processing for sure, and it's doing important things, but most of the variability that we see, for example, in how good you are, relates to activity in motor areas. So there does seem to be something about processing things in time that unfold that the motor system either is particularly good at or has a lot of experience with. And then evolutionarily, this idea comes from, well, when you wanted music, even 200 years ago, you had to make it yourself. And that required some form of bodily movement. And so it's only recently that we can just press a button and have all of this rich musical experience in our ears. Right. But because of this, the way that music evolved, it always had to be produced by a person. Therefore, we perceive it, and this is part of the field of embodied cognition, as being produced by a person. So when the music is fast, we think of it as high energy because in order to produce fast music, a person would have to move a lot and use a lot of energy. So even though that's not the case anymore, again, you can press a button on a computer and it can produce tremendous numbers of notes with no effort whatsoever, we still process it as if that human element was there. And so there's some idea that, again, with rhythm, that like that's how you synchronized with it, that this was something meant to be moved to because people were involved in the making of the music rather than, passive concert listeners like we have now where people sit quietly and don't move at all.
Interesting. Okay, yeah. That's so interesting to think about. That's been on my mind for a while. Like I do that often as well, like tapping my foot or jamming out to music. And I've wondered like what could be like a mechanistic or cultural explanation behind it even. Kind of moving back to Parkinson's, I did have a question about kind of music therapy as well. So does music therapy kind of have the potential to not replace, but almost like complement traditional Parkinson's treatments? Or do you see that becoming like more prominent in this field?
I certainly hope it becomes more prominent. It absolutely can be very helpful. Again, sometimes even just the fact that music makes an intervention enjoyable or interesting or fun. And because music is something that people enjoy moving to, even if they're not very good at it often, that can be really helpful in all of the motor type rehabilitation that's necessary. And then there might even be on top of that, based on the work that we've been doing, something special about music's ability to drive movement that could be particularly helpful here. So yeah, I agree, it wouldn't be a replacement. Music therapy probably isn't causing, dopamine cells to reverse their death course, but certainly the thing after a diagnosis that's important is to, engage in these therapies that keep your mobility and keep you active and socially engaged. And music is a really natural support for a lot of those things.
I see. Yeah, so it's like a nice additional thing. Obviously, it's, as you said, it's varied between people. But for people who is effective, it is noticeably it can kind of better their symptoms.
Yes, and often there are mood-related effects too, because again, it's enjoyable, it's fun. You feel like you've accomplished something when you're moving to music. It's so those can just, we think of them as side effects or side benefits, but actually they're treating core problems at the same time.
Right. Okay. Kind of moving on to nearing the end about closing personal insights. Thank you so much for answering all my questions about music and Parkinson's. What challenges do kind of Parkinson's research or this area kind of still face in your opinion?
There's still a lot we don't know, for example, about how it arises, and there's a lot of variability. Some people have real tremor dominant types of Parkinson's. There's also a more postural and instability and gait disorder type of Parkinson's. And they seem to have different components that go along with them. There are some really interesting things for example, loss of smell or REM behavioral disorder. So people act out their dreams. Seem to be precursors to Parkinson's diagnoses.
Oh, I see.
Some significant portion of the time. So where does that come from? What's going on? And then understanding, again, this variability, both in response to our stuff that we're doing with music, but also to other types of treatments. I think there's a lot we don't know about exactly how the disease arises and the different patterns that it takes that people are actively working on.
I see. Okay, that's cool. That's interesting. And if music as well could eventually become some sort of a standard therapeutic tool, what could that look like in clinical practice maybe?
I think, there are people who are more expert about what this might look like practically, but I certainly think it could be integrated very well with the sort of occupational therapy and physical therapy that most Parkinson's patients do receive over time.
Right.
So that to me would be a natural place for that to come in. But I am also hoping that we can empower people themselves. A lot of these things are easy to try out and they don't have a lot of harmful side effects. So if we can explain to people, well, these are the types of music and how we select them that we have found are more likely to be helpful, they can go away and experiment themselves. And so I think that could be nice as well, providing people with toolkits that they can use. And now with all of the wearable type of technology we have, they can get feedback about, oh yes, that is improving your gait, or nope, that doesn't seem to be helping you. That can complement their own sense of whether it's helping or not. So I think there's some fun stuff to be done there.
Yeah, I remember I did a presentation about music and Parkinson's with a few of my group members, and I think one of the benefit we kind of talked about or mentioned was the fact that music is very easy to implement, even in your own home. Whereas some treatments or other things physical therapy is great, but sometimes you need to go somewhere. But music you can't listen to at home, or some really other more invasive techniques DBS is proven to be good, but it's a lot.
Right.
Whereas music is, you can implement it easily, you can do it at home, and I think that's might be one of the benefits.
Yes, absolutely. Yeah.
What gives you hope for research in Parkinson's, despite all this unknown variables?
Yeah, sure.
Yeah.
I think just the number of very smart people, not me, but other people who are really working hard to figure out what we can do to help, how we can prevent it, how we can treat it from all sorts of different angles. That to me is very exciting, and that we're just getting more and more tools to be able to look and manipulate brain activity, sometimes in animals, sometimes in humans, and really get to understand with much finer grained tools what's going on. Something like fMRI, which is mostly what we use in humans for brain activity these days, is very coarse, and so it'll be very limited what we can do for some of these more molecular based diseases. So yeah, I think the smart people working on it is definitely a good sign for everyone.
I see. Do you foresee a future where these neurological, neurodegenerative diseases, not even Parkinson's, maybe even Alzheimer's, Huntington's, Parkinson's, do you see a future where there is a cure for these types of diseases?
I do. To me, it seems feasible. And whether that's something that we do based on early diagnostics, because we have an idea of what goes wrong and then how to prevent it, or something where, it's about better treatments or undoing some of the damage. Yes, I have optimism. Maybe not in my lifetime. That feels more ambitious, but this is the interesting and fun thing about science is that sometimes a breakthrough happens and nobody expected it. So yeah, I'm optimistic.
I guess it's like almost like a collaboration of like humanity. Like maybe not on our lifetime, but our goal is, at least for the people in academia, is to do research, expand the topic, so maybe one day someone else could expand upon it,
Right.
and then reach like a certain point.
Absolutely.
Right. One question I had for you was like, what keeps you motivated in your own field?
I think over time, the biggest motivation is really training people who will then go on and do cool things. Training people about how to think about good scientific questions, how to correctly analyze data, how not to be scared of statistics, that they're a tool. These are all things that, for me, I find more motivating. Because whatever I find about music in the brain is going to be like out of date in 100 years. It's not going to matter, right? We're going to have a much better idea of what's going on, or at least I hope we do. So what I specifically find or study, I see as part of moving things forward in general, and not the achievement itself. And the best part about moving things forward really is finding people that have that spark, have that interest, and just giving them what they need to go forward and carry on in whatever they're interested in. So for me, that I think is the real motivating factor.
That's amazing. I think that's great. And kind of like my final question to you would be, what advice would you give to students kind of interested in maybe research or neuroscience?
Yeah, I mean, it's amazing what you can learn online these days. So dig in, see what really grabs you, and then talk to people again, because science very much is this collaborative field. And a big part of my considerations when I'm looking at students is, are they succeeding in their classes? They're able to get that knowledge. But a lot of it is like, oh, I'm very interested in this, and I am going to learn about whatever you have to teach me, and I just want to be involved in any way possible. That enthusiasm really comes through. So I think if you can find the thing that really drives that enthusiasm, or several things, like I said, often there are lots of different areas that people can go, and then try and find graduate students and researchers and PIs who are doing that and talk with them about it. We also have on campus, it's often under-advertised, I think, to undergraduates, but we have these world-class scientists coming in basically every day somewhere on campus as somebody who's an expert in their field talking about it. And so attending those, it's so much easier than slogging through papers when someone's telling you about their work and helping you understand it rather than just you reading. So I think that is an opportunity that people could take more advantage of.
I see, yeah. Attending, I get a lot of emails, but I think the issue is maybe most people don't check their emails too often.
Sure.
Yeah.
No, and it needs to be targeted appropriately. Like somebody in one department isn't necessarily going to be interested in what's happening in this other area, and if you get flooded with them, you'll tune them all out. So some selective targeting is helpful.
I see. But for students, like, be curious, enthusiastic about research. Attend these, like where an expert talks about their field, and maybe that could like increase their curiosity or enthusiasm.
Absolutely, and ask a question.
Questions, right. Okay, well, that's it for the podcast today. Thank you for joining us so much.
Oh, thank you for having me.
Thank you very much, and that'll be all. Thank you.
Great.